Steps for solving logarithm equations. First, you're going to use those properties that you learned yesterday to write each side as one log. And then you're going to use the fact that the inverse of logarithms is exponentials and base both sides, so that'll cancel out the log. You're literally going to make both sides become the exponent. And then next you're going to solve. So for example 1, a lot of students want to try to cancel out the 6 first, but you have 2 on this side and 1 on this side. So the way you squish it into 1 is by using those properties. Since you're plussing here, that means you can rewrite it as using the product property as 1 log, so log base 6, of the product. So negative x times 7, that's a negative 7x. Now that I have both sides written as 1 log, I'm going to base both sides base both sides. And what I mean by that is I'm going to use the base of the log, because the inverse of log base 6 is 6 to the something power. And so what that does is that cancels out the log base 6 and that, so those go away. And so what we're left with is negative 7x is equal to 26. So divide by negative 7 and x is equal to a negative 26x. And that is your final answer. Alright. Example 2 is a little bit different. Example 1, you had logs on all sides. Here, you don't. But you still have 2 logs on one side, so you still need to condense it before you can base it. So your first step is to use the properties. Again, since we're adding here, that means we can multiply these. So that means it'll be log base 8 of 12x is equal to 2. Now, to get rid of that log base 8, because when you're trying to solve for x here, you're going to need to base both sides. And since our base is 8, that means we're going to base both sides 8. And just to be clear, I'm using the little caret hat thing to represent, this is now the exponent. So what that means is 8 to the log base 8 of 12x is just simply 12x, because those cancel each other out. And this is 8 to the second power, so we bring down 8 squared, which is really 64, and divide by 12, and x reduces to 16 over 3. The next example is just to give you a natural log example. All of the rules are the same. You first want to use the properties to condense both sides to 1 log. And usually you just have only one side that has more than 1 log, but if you had more than one over here, you would do the same thing and condense it. So since you're adding here, that means you can rewrite this as the product. 5 times negative 4x is a negative 20x. Now, when we base both sides, here you have to remember what's the base of natural log. The base of natural log is e. So the e to the natural log will cancel each other out, and you're left with negative 20x is equal to e squared. To solve for x, go ahead and divide by negative 20. So x is equal to a negative e squared over 20, and honestly, I like that answer best, but you might have to approximate that, so make sure you know how to put that in your calculator, and that is approximately a negative 0.369. Alright, last one. Again, your first step is going to be to condense your logs into 1 log. Now this is the first one we've had subtraction here, but remember subtraction is quotient. So that means you can rewrite this as 1 log, but instead of multiplying, you're going to be dividing. So this becomes log base 3 of x squared minus 1 over 7 is equal to 2. Okay, next we're going to base both sides 3, because our base is 3. So I'm going to base it 3. Those two are going to cancel, and I'm going to bring down x squared minus 1 over 7 is equal to 3 squared. 3 squared is 9. So now I'm just trying to solve for x. So I can multiply both sides by 7. And I have x squared minus 1 is equal to 7 times 9 is 63. Add 1, and x squared is equal to 64. Square root both sides, and x is equal to positive or negative 8. And those are the basic steps to solving any logarithmic equation. There are a few more things you'll need to watch out as you move along in these, but these are the basics.